Here we have a SAT math problem. Okay, let's go to the question. 3x negative 7p times 5x square positive 8x negative 4p, x cube positive 3x square negative 16x negative 48 equals to 0. In the given equation, p is a positive constant. The product of the solutions to the equation is a negative 560 over 9. What is the value of p? Okay, when I consider the stuff on the left side of the given equation, we have the product of three expressions. Okay, whenever the product of three expressions equals to 0, then the one of them has to be 0. That is, first one has to be 0, or the second one has to be 0, or third one has to be 0, because the product equals to 0. Okay, if I consider the first one is equal to 0, I am getting the equation 3x negative 7p equals to 0. And it's a linear equation, then we'll have only one solution for this equation. That is, we'll have only one value for x. Okay, now let's solve for x in this equation. Let me add 7p to both sides. When I do so, this negative 7p, positive 7p will cancel out. I am getting 3x equals to 7p. Let me divide both sides of this equation by 3. Then this 3 will cancel out. I am getting x equals to 7p over 3. Okay, when I equate this one to 0, I got a linear equation, and the solution for that equation is 7p over 3. Okay, now if I consider this one is equal to 0, I am getting a quadratic equation, that is 5x square positive 8x and negative 4p equals to 0. Since it's a quadratic equation, we'll have two solutions. Since the product of the solutions for this equation is given, what we can do is we can get the product of two solutions of this quadratic equation. For that, we can consider a quadratic equation standard form, that is ax square positive bx positive c equals to 0. When we have a quadratic equation in standard form like this one, there is a formula to get the product of the two solutions, that is equal to c over a. That is, we have to divide the constant term by the coefficient of x square. Okay, now we can use the same formula to get the product of two solutions of this quadratic equation. Okay, let me write it out here. So the product of two solutions of this quadratic equation equals to, we have to divide the constant term by the coefficient of x square. Then we get negative 4p divided by 5. Okay, here when I equate this one to 0, I got a quadratic equation, and I got the product of two solutions, that is negative 4p divided by 5. Okay, now let me erase this stuff and equate the third one to 0. Now let me equate the third expression to 0. Then I'm getting x to the third part, positive 3x square, negative 16x, and negative 48 equals to 0. Okay, now I think we can solve this one by factoring. Okay, let me factor the expression we have over here by grouping. Let me consider the first two terms as one group and the next two terms as another group. Okay, when I consider the terms in the first group, the greatest common divisor for this one and this one is x square. So what we can do is that we can factor x square out. Then we get x positive 3 inside the parenthesis. And when I consider this one and this one, the greatest common divisor for these two terms is negative 16. We can factor negative 16 out, then we get x positive 3 inside the parenthesis equals to 0. Now we can consider this is one term, this is another term, and for these two terms, the greatest common divisor is x positive 3. So we can factor x positive 3 out. When x positive 3 is factored out, we get x square negative 16 over here equals to 0. Okay, x positive 3 times x square negative, we can write this 16 as 4 square equals to 0. Okay, now let me consider an algebraic identity, that is the difference of two squares, a square negative b square. Okay, whenever we have difference of two squares in this form, it can be written in the factor form, that is a positive b times a negative b. Okay, when I consider the expression over here, x square negative 4 square, it's exactly in this form. So we can write this one in factor form, like a positive b times a negative b. For that, we have to take x at the place of a and 4 at the place of b. Okay, now let me write it, x positive 3 times. Now we can write this one in factor form, like a positive b times a negative b. Then we get x positive 4 times x negative 4 equals to 0. Okay, here the product of three binomials equals to 0. Since the product of three binomials equals to 0, one of them has to be 0. Okay, if the first one is 0, we get x positive 3 equals to 0. If the second one is 0, I'm getting x positive 4 equals to 0. If the third one is 0, I'm getting x negative 4 equals to 0. Okay, if I solve for x in the first one, I'm getting x equals to negative 3. And if I solve for x in this one, I'm getting x equals to negative 4. And in this equation, I'm getting x equals to positive 4. Okay, now let me get the product of three solutions. There is negative 3 times negative 4 times 4. Okay, when I equate the third expression to 0, I got the product of three solutions. Okay, now let me write it over here. There is a negative 3 times negative 4 times 4. Okay, here I got the product of all the solutions to the given equation over here. According to the given information, the product of the solutions to the given equation is equal to negative 560 over 9. So it must be equal to negative 560 over 9. Okay, now we have to solve for p in this equation, and here we can do some simplification. That is 3 goes into 3 one times, and here 3 goes into 3 one times. Okay, now let's multiply this 7, negative 4, and negative 1, and negative 4, and 4. Okay, before that, first we can multiply the signs. Okay, negative times negative will be positive, positive times negative will be negative. And when I multiply the numbers 7, 4, 1, 4, and 4, I am getting 448. And here when I multiply this p and p, I am getting p square. In denominator, we have 5. That is 1 times 5 is 5 equals to negative 560 over 9. Okay, here we have negative sign and here we have negative sign. Let's multiply both sides of this equation by negative 1 to get of the negative sign on both sides. When I multiply this one by negative 1, I am getting 448 p square divided by 5. When I multiply this one by negative 1, I am getting 560 over 9. Okay, now to get of this 448 over 5, let me multiply both sides of the equation by the reciprocal of this fraction. That is 5 over 448. Let me do the same thing over here. That is 5 over 448. Okay, this one will cancel. This one will cancel out. I am getting p square equals to here this 560 and 448, both of them are even numbers, and we can simplify this one. For that, we can write a fraction with this one as numerator and this one as denominator. Then I'm getting 560 over 448. And we can write another fraction with this one as numerator and this one as denominator. Then I'm getting 5 over 9. Okay, now we can use Desmos graphing calculator to get the simplified form of this fraction. When I use Desmos, I am getting 5 over 4 as a resulting fraction for this one. Times we can write this one as it is, that is 5 over 9. Okay, p square equals to, when I multiply this two numerators of 5 and 5, I'm getting 25. And when I multiply the two denominators, I'm getting 4 times 9 is 36. Okay, our aim is to get the value of p. So we have to get of the exponent 2 over here. Now let me take square root on both sides to get of the exponent 2 over here. On the left side, the square root and square will cancel out. Usually when we take square root on both sides of an equation, for this square root, we have to consider positive or negative sign. Okay, then we get p on the left side, positive or negative. And when I take square root for the numerator 25, I am getting 5. When I take square root for the denominator 36, I am getting 6. Okay, here I get two values for p. One is p is equal to positive 5 over 6, and the other one is p is equal to negative 5 over 6. The question says p is a positive constant, so we can reject the negative value of p. Therefore, the value of p is 5 over 6.